The particle with that charge and that mass, wait, that looks like an electron. Moves along the positive x-axis from left to right. Enters a 3 Tesla magnetic field in the xy plane, points 45 degrees above the positive x-axis. Which direction of the force of the particle? So there's my x and y axes, and there's my direction. So you can see v, the velocity, points towards the right, and the magnetic field points up at an angle 45 degrees above the x-axis. I put a hand on there, so the thumb points towards the right, the fingers point along the magnetic field. The palm is the direction of the force on a positive charge. That would be directly out of the screen, so be out of the page. But if you notice, it was a negative charge, therefore it's going the other direction. So a negative charge is into the page. Out of the page is the positive z direction, into the page is the negative z direction. After the particle has been in the magnetic field, the particle moves in a circle. If the radii of its path is that big, what is the speed of the particle? Well, the radius is mv over qb, and you can see we have some various things here. We've got our charge, that would be q. We've got our mass, we've got our magnetic field, and we have the radius right there. So we can fill all those in. Multiply by the, notice I made the charge positive. It's kind of an absolute value thing. It's not a vector, so positive, negative doesn't matter here. So I'm going to multiply by the 1.6 times 10 to the negative 19 and the 3. And then divide by the 9.11 times 10 to the negative 31 kilograms, to solve for V, and V is approximately 105.4 meters per second. If we use significant figures, of course, it'd be 100 meters per second. A particle with a charge, oh, this is the same problem we just did, just extending it. So what is the magnitude of the force on the particle? Well, force is QVB times sine of theta. All right, our charge was 1.6 times 10 to the negative 19. Again, I made it positive because we're not doing a vector at the moment. We got our direction of the force from the right-hand rule. Our velocity was 105.4. That was from the last section. And our B is 3 Teslas. And our angle is 45 degrees. Multiply those together, and your force is 3.58 times 10 to the negative 17 newtons. And its direction was in the negative z. That's it for today.